Thank you, Kyle. Good afternoon, and thank you for joining our webinar today on optimizing weld inspection with the Mentor EM. I'm Dave Jankowski, the ultrasonic and eddy current product sales leader for GE Inspection Technologies. Over the next 30 minutes, Dan Groninger, the engineering leader for the Mentor EM, and I'll be reviewing the changing landscape in NDT and how the Mentor EM can help address some of these inspection challenges. As Kyle mentioned, he has muted all of the phone lines, and we'll reopen the lines for questions and answers at the conclusion of this presentation. You can also send questions via the chat box located in the lower right portion of the screen, where one of our online Mentor EM experts will quickly respond to your question. The landscape of NDT has changed significantly over the past 15 years. We have an aging NDT inspector population, where level 3s are retiring and moving out of the business. And there are a lot of questions on how to train the next generation of inspectors to ensure that this legacy knowledge is passed on in an efficient manner. Inspections are becoming increasingly more complex due to compliance concerns, due to increased capabilities of different NDT inspection processes. There are more demanding environmental health and safety regulations. One that we're going to specifically be addressing this afternoon is looking at eddy current as an alternative to liquid penetrant and MPI for weld inspection. And there's always the drive for improved probability of detection and productivity. In order to address these new inspection challenges, GE Inspection Technologies has introduced the Mentor Platform. The Mentor Platform looks at leveraging advancements in digital electronics, packaging, and display technology, which is currently available out on the marketplace in a lot of consumer products. The Mentor also uses downloadable, customizable, or standard applications for NDT inspection. The second portion of today's presentation will really focus on the value these applications can bring to your inspection process and the ease of developing them. The third area is integrating wireless communication into NDT instrumentation. This can allow immediate collaboration with remote experts between the remote expert and the field inspector. I'd like to talk a little bit about considering eddy current as an alternative to liquid penetrant and magnetic particle inspection. Eddy current does not require a lot of the consumables or any of the consumables that are currently required with LP or MPI. Items such as penetrant, developer, and cleaning liquids that are required during an LP or MPI process are not required with eddy current, nor is the cost to completely dispose of these items after their use. In addition, eddy current allows you to perform the inspection through a non-conductive coating, eliminating the need for pre-inspection coating removal or post-inspection recoating or repainting. If you look at a typical return on investment for a medium-sized refinery who's undergoing an annual or biannual inspection turn, typically about 10,000 welds. If you look at the cost of doing a liquid penetrant inspection, you have to account for the cost of the chemicals. You have to account for the man hours for the pre and post inspection tasks, as well as the time for the actual inspection, and then of course add to that the cost of the disposal of the spent chemicals. Eddy current requires a one-time capital investment for the eddy current product and a significantly lower amount of inspection hours. Each refinery or application is specifically different, and you can do a specific return on investment for your facility or your customer's facility with a return on investment tool that GE Inspection Technologies offers. Eddy Current is an approved inspection procedure for weld inspection. As you can see, we have an ISO and DIN inspection number that's been approved for eddy current examination of welds by complex plane analysis. In addition, eddy current is an improved inspection method for weld inspection by a number of global approval bodies such as Lloyd's Register, DNV, and Bureau Veritas. The Mentor EM is a full-featured eddy current flaw detector. We're used in conjunction with our WeldScan probes provides an effective, efficient, and reliable means to do weld inspection. In addition, the Mentor platform offers you the capability to customize the interface and develop inspection procedures which can be uploaded directly onto the instrument. The picture on the right-hand side shows a typical WeldScan inspection probe. As you can see, it is handheld. In this case, it's just scanning over indications or notches on a test block. The advantage of the WeldScan probe is that the eddy current coil design minimizes the effective surface roughness, something which we call liftoff. By minimizing liftoff, it allows us to be able to quickly ascertain and to determine the presence of other indications representative of cracks in the material. As you can see in the figure on the right-hand side of your screen, we have the minimal liftoff showing, and then the green signal going to the upper right at about the 1 o'clock position is the eddy current signal. And we'll be demonstrating that to you in real live time shortly. There are a wide number of eddy current WeldScan probes available to accommodate all different types of weld geometries. In addition, we offer a ceramic version for high wear applications and a high temperature variant, which can be used up to a little bit over 400 degrees Fahrenheit in continuous use. This is a photograph of a WeldScan inspection kit that contains a number of different WeldScan probes, associated cables, setup test block, and Teflon tape, which is typically used to coat the probe to decrease the amount of wear on the surface of the probe. What we would like to do now is I'm going to be passing the presentation over to my colleague, Dan Groninger, and Dan will walk with you through a typical WeldScan inspection on the Mentor EM.
All right, hello everyone. What you're seeing right now is a view of the screen of my Mentor EM instrument. I have it shared with my computer to be able to put it across the WebEx. As you may have noticed in the picture that Dave had of the instrument in an earlier slide, there were no knobs, buttons, or any other controls visible on the face of the instrument. There's exactly one hardware control in this instrument, and that is the power switch. If you're familiar with smartphones and tablets, you'll be very comfortable operating this instrument. We use a projected capacitance touchscreen, which means it's very compatible with gloves. You can use nitro gloves. We've tested it with U.S. military chemical warfare suit gloves, and there are also a wide variety of work gloves available, heavy leather work gloves available these days, with fingertips that are designed for operation of touchscreen. It's also a very tough touchscreen. The screen itself is a chemically strengthened glass, so it stands up very well in tough, dirty environments that we often get into with inspection. So you'll notice this is one, what you're seeing here is one slide of a application for weld inspection. On the left-hand side of the screen, you can see some instructional material and a reference screenshot of an indication. On the right-hand side of the screen, you see the impedance plane view or list issue view of the data. I have one of the weld probes that Dave had pictured earlier. I placed it on my calibration standard. And of course, the first thing we usually do in Eddy Current is a balance. Balance the instrument, run it across a 1 millimeter deep notch, and there's the indication from the notch. Because of the construction of the weld probe, if I turn it 90 degrees and go across the notch the other orientation, I get a signal indication that's 180 degrees out of phase on the screen. I'll freeze that signal for a second. Now I can use my fingers with intuitive gestures to change the phase angle. I'm just doing a rotating gesture on the screen. I can grab the origin of the display, move it around with my finger. I can tap in the middle, recenter it, and change gain of the signal just with a pinch gesture. If I want to open one of the menus, I can open the menu and make adjustments to the data using menu controls as well. Some controls are keypad, so parameters where you would naturally enter something directly as a number, we provide keypads for. Others that might be handier as sliders, we provide sliders. All of these things are handled with intuitive gestures. So we'll get back to, in a few minutes, we'll come back to how one goes about creating these apps. These are completely user configurable, and you can have a large collection of them on the instrument. So with that, I'll turn it back to Dave.
Thanks, Dan. As Dan, mentioned, we have tremendous power in the Mentor EM, and it really allows you to optimize the weld inspection experience. You can easily customize the interface to optimize the Eddy Current inspection, which is unique in NDT product. Right now, with the typical NDT product, once you turn it on and once the screen lights up, that interface is the interface that you have to continue working with. The Mentor EM allows you to customize that interface, and we'll be demonstrating to you how easy it is to do that. You can design the signal presentation. You can decide the size, the location on the actual instrument screen. You can do this to accommodate inspector preferences. Perhaps if you want a large balance key, you can easily drop one in. And you can develop step-by-step inspection procedures to assist the inspector during the process, during the procedure. You're allowed to embed graphics, videos, and photographs. And of course, you can control full access to control the key parameter settings. In order to do this, we've developed a tool called Mentor Create to customize this inspection experience. It's as simple as a PowerPoint type application where you drag and drop items on the screen, whether it's a signal display, whether it's a text box, a PDF, or a video. You simply drag and drop and do the final adjustment. You can limit parameter ranges. And as we've discussed, you can add figures, photos, and videos. Once you've developed the application or the workflow in Mentor Create on your PC, you simply upload it into the Mentor EM, either via USB or via Wi-Fi. So this allows you to take the Mentor EM, which is a full-featured Eddy Current flaw detector, and then further optimize it for your inspection. I'm going to walk through a typical guided workflow for weld inspection applications, just to kind of show you some of the power of what Mentor Create and a Mentor Platform can offer you. first panel or screen which the inspector will see in this case is the simple purpose of the inspection process. You know, there's a fast link there to a PDF of the procedure that would be of value. Another example is the second step would be looking at the equipment used. Perhaps it would be of value to list the part numbers of the equipment being used. They have a photograph showing what they look like, or even in this case, having a drawing of the test standard to aid the inspector. Moving on to a coding assessment screen where we listed different steps for the process on the left-hand side of the screen. All the time, the operator can see the real-time eddy current response on a LIGU or impedance plane display on the right-hand side. Think about the value there. Instructions on the left, live screen on the right side, live signals to really help facilitate and ensure, for example, that the calibration is being done consistently. It'll add tremendously to the confidence of your inspector as he performs the setup. Similar for weld inspection, in this case for calibration. Again, instructions on the left, step by step, with a live LIGU on the right side. So the inspector only has to look at a single screen instead of perhaps a eddy current screen and an adjacent document in a binder or book, for example, or on an independent or separate PC. We can add videos and figures. Perhaps with some processes, it's a lot easier to shoot a quick video with your iPhone than upload it into Mentor Create to really allow you to illustrate how the inspection should be done. And then on the final inspection screen, in this case we're monitoring coating thickness concurrent with the flaw detection on the same screen. A lot of power, you know, and you can determine how involved or how simple you want the inspection to be. Just to show you some of the other capabilities of Mentor Create in terms of customizing the interface, you can dictate what screens you want where, or what signal displays you want on the actual screen. You can put in multiple balance buttons. You can change designations and names. As Dan will be walking through with you, you can go through and you can actually set boundaries on adjustments. If you feel that would be of help, you can eliminate different parameters, or you can hide different parameters, which perhaps are not, you do not want adjustments to be made. You have all of that power within Mentor Create. What we're going to be doing next is, Dan, I'm going to be passing the ball back to Dan Groninger, and Dan is going to be taking this inspection procedure, the simple 3-page weld inspection procedure, and creating the application on Mentor Create. I'm going to be passing it back to Dan.
Okay, I've got what you're looking at right now is the screen of my PC. I've got the Create program open on the PC. And to save a little bit of time, I'm going to start by importing an application that we've developed previously, called GE Weld Procedure. And I'm going to clone that, make a copy of it, give it a new name, GE Weld Webinar. And just that quickly, I've made a copy of that we're going to work with. I double click on that to open it. And here are the panels that make up the app that we're going to run on the Mentor instrument. So this particular one has 1, 2, 3, 4, 5, 6, 7 panels. You can think of the panels as being similar to slides in a PowerPoint presentation. And on any panel, you can have a mixture of data views, instrument control, and instructional material. On this first panel, we have all instructional material. Let's say one of the first things we'd like to do is get rid of the GE logo and put something more appropriate to a weld inspection there. And that quickly and easily, we're able to replace the logo with a picture of a welder. You can see there's a go-to button on here that you can jump to a PDF view. It happens to be in the last panel. You go there, there's a PDF viewer. So any kind of Adobe Acrobat format documents can be displayed, paged through, all the normal things you would expect there. Back at the beginning. One thing I should point out, the instrument itself is very powerful, very versatile compared to many portable eddy current instruments. For about the same price as a 1 or 2 channel eddy current flaw detector, we're providing you with an instrument that has 2 complete sets of eddy current electronics. Each one of those eddy current inputs is capable of running up to 5 time slices multiplex, and on each time slice and input, you can run up to 4 frequencies simultaneously. So you can do simultaneous injection and demodulation on anywhere from 1 to 4 frequencies per time slice per input. So that gives you a total of up to 40 channels available for evaluation. On this application, we have just 1 channel, keep things simple, and this is where you would set up some of the essential parameters for the front end, the WeldScan bridge mode, the frequency, drive voltage, and so on. The most familiar view is the layout view. We could add additional instructional information. In this panel, for instance, let's add an excerpt from our document that will give the inspector some guidance on what area of the part being tested you should be scanning with this probe. So I'll add a rich text box. I will jump over to a PDF viewer where I happen to have the document open, take a snapshot of this area of the document, copy to the clipboard, back here, Control V, paste it in, resize my view a little bit, and drag that to the center of the slide. That's simple. The next step on calibration. Now, this was the panel we looked at earlier when I showed you a view of the instrument. You have instructional material and reference documentation on the left. On the right, we have a data view, the list issue view. So maybe we'll make that a little bit bigger. And let's say there are certain parts of the menu, certain parameters that I don't want the inspector to mess with in the field. Or I want to simplify things for the inspector. So since we only have 1 channel operating, there's no need for a channel selector. I can just click that off, and you notice the parameter disappears from the menu. And we can turn off the channel enabled too. There's no point in disabling your only running channel. And let's say we want to lock drive voltage so that it cannot be changed. And simply come over here to the properties and click lock. And actually, we want to change that back to 8 volts. We'll just let that play it is for now. That'll be fine. So going on to the next panel. One of the things that you can include in terms of instructional material are videos. I'll put in a video of the methods used for scanning the weld. And you'll be able to see that on the instrument. Now, you may not be able to see that because of the way WebEx works. You may not see running video in there right now, or you may not see it later with the instrument, but the instrument operator will be able to view that video. So one of the things we're going to do here is resize our list issue a bit, and we'll make it square. And you notice we have a free-floating control out here. We've added a balance button. One of our customers actually asked for this because the balance button down here at the bottom is a bit small, and he asked for a nice big button so that he could hit it more easily when he's out in the field doing inspection. And then his buddy said, well, that's fine for a right-hander. How about having one on the other side, too, for a left-hander? So just that easy. Looking in here, we say balance input 1, we drag that button out, and we place it on the left side of the screen. Okay. The final page we looked at earlier is a PDF viewer. There's nothing we're going to change there, so we're going to hit the button to save our work. We go to the build step. Click build. I point it to my USB memory stick. It says, hey, this already exists because I was working on this morning. Tell it to overwrite. And what it does is compiles everything for the app together into one file, puts it on my memory stick. Now we're going to switch back to the remote view of my instrument. Over here, plug the memory stick into the instrument. And you notice down here in the lower right corner is a little plus button. Press that. It goes to the memory stick, shows me a list of all the apps that I have on the memory stick. I scan down to the one we just created, GE Weld Webinar. We add that. That quickly it is installed on the instrument. I can now run that app. Notice there's a large collection of other apps that I have on the instrument. So there's our first page. We can see our welder. In the corner, that panel we didn't make any changes to. There's a bit of instruction showing the area that we're going to be scanning. In this step, we come in and we calibrate balance, calibrate on a notch. We're going to give it a little more gain. There's our signal. Go to the next step. There's a video there. Again, I don't believe that's going to show very well on the WebEx, but it's running on my instrument. And here's the panel that we made with the two balance buttons. I can have a piece of welded steel here with a very rough weld on it. Put my probe down, hit one of the balance buttons. And as I run along the probe, you can see a little bit of noise from the roughness of the weld. And right there is a crack in the weld. We go to the next panel, we have our PDF. There's 3 pages to this. I can open the table of contents. I can scroll through the thumbnails and select a page. And if I want, I can zoom in, I can pan around. You know, all the things that you might expect to do with a document. So that's it. I think that's our prepared demonstration for weld inspection.
Thanks, Dan. You know, as Dan has just walked through, you can see how easy it is to put together a customized inspection based on the Mentor platform, generating it in Mentor Create, and then simply uploading to the Mentor EM via USB stick, as Dan did, or even via Wi-Fi. The beauty is this allows for easy deployment off-site to perhaps other mentors within your fleet by either just simply emailing the application. You know, in conclusion, just want to walk through one more time some of the advantages of the Mentor platform and the Mentor EM for weld inspection. We talked about how Eddy Current is a environmentally friendly and approved NDT technique for weld in inspection applications. Mentor EM allows rapid weld inspection by all levels of inspectors, from the expert to the newly qualified. Mentor Create facilitates that by allowing easy customization of the user interface to suit the application and the skill level of the inspector. And the workflows can be easily transferred not only from a PC to the Mentor, but can be used by simply emailing it or sending it wirelessly. Your next steps for the Mentor EM. You know, if you believe you have interest in applications for the Mentor EM Eddy Current solution, contact your local GE Inspection Technology sales engineers. to discuss your Eddy Current application and to arrange to receive a copy of Mentor Create software at no charge. We are giving that away right now at no charge. You can experiment with it to develop applications. Then you can arrange an on-site demonstration of the Mentor EM for your application. And as a thank you for attending the webinar this afternoon, we're authorizing a 10% discount for all webinar attendees for Mentor EM orders placed by December 24th, 2015. That concludes the presentation portion of the webinar. Again, thank you for your time on this Tuesday afternoon, and I'm going to turn it back over to Kyle. Kyle?
At this time, if you'd like to ask a question, press star and the number 1 on your telephone keypad. We'll pause for a moment to compile the Q&A roster.